Hello, this video is for textbook lesson 2.4, that's from chapter 2, and this is lesson 4. The title of this lesson is Variables and Equations. The objective here is that you'll solve equations with variables. And our vocabulary is equation, solution of an equation, and solving an equation. So our example is a biology example. It says that lotus flowers, like the one shown, can be grown from seeds hundreds of years old. In example 4, you'll see how an equation can be used to estimate the year when an ancient lotus seed was formed. So we have a couple of vocabulary words. We know that our vocabulary words show up in yellow. So an equation, we've been talking about expressions for quite some time, so now we're going to talk about equations. An equation is a mathematical sentence formed by placing an equal sign, and we know what an equal sign looks like, between two expressions. So those expressions that we've been dealing with, like 3x plus 4, notice I didn't include an equal sign. Now if I said 3x plus 4 equals 12, then now I have an equal sign, and instead of an expression, it is now an equation. Also, notice I'm going to highlight the root word here notice that all but the L, see the word equal there, E-Q-U-A-L, that the word equal is the root word for the word equation. So one way to remember that equations have equal signs is because we can see the root word equal in the word equation. A solution of an equation with a variable is a number that produces a true statement when it is substituted for the variable. And we've done some substituting before in the past, so we understand the idea of substituting. So let's go ahead and move along to the next page. Example 1 is writing verbal sentences as equations. Well, we've wrote verbal sentences as expressions before. That means that we've done things like the sum of x and 6, x plus 6, or the difference of 12 and y, that would just be 12 minus y, or the product of negative 4 and p, negative 4 and p being multiplied because we understand product means to multiply, or the quotient of n and 2, which would be n minus 2. But one thing that we've noticed now is that we're adding what word? If you've noticed that the word is now here as well, that's a good indicator that is must mean equal sign. So the word is we represent mathematically as an equal sign, and other things might be equal to. We could say the product of negative 4 and p is equal to 32. The same as would be another possibility. We could say the sum of x and 6 is the same as 9. So these are all phrases that represent equal signs here. And likewise, the word is also shows up as an equal sign. And we know that sum is addition, and we know that difference is subtraction, and we know that product means to multiply. And since there's no sign between the negative 4 and the p, we know that this is multiplication. And the quotient is division, and we've talked about that every fraction is indeed a division problem. So let's go ahead and kind of clean that up a bit. So we see that we can take a verbal sentence like this and write it out using numbers, operation signs, and equal signs, and possibly variables, and so forth. So we'll do some of that in our Excel activities. Example number 2, checking possible solutions. Remember that back here on page 1, we saw that a solution of an equation with a variable is a number that produces a true statement when it is substituted for the variable. So that's what we're doing here, is we are substituting in for the variable to see if it produces a true statement. And over here on the left, reading algebra, we have 3 symbols: equal sign with a question mark above it, and an equal sign with a line through it. equal sign means is equal to. With a question mark above it, it's asking you a question. Is it equal to? And then an equal sign with a line through it, well, that's not equal to. So in general, when you see a question mark above a relationship symbol, such as an equal sign, a question is being asked. A relation symbol with a slash through it has the opposite meaning of the same symbol without the slash. So without the slash means equal to, and the opposite of equal to is not equal to. So that's the one with the slash through it. So tell whether 9 or 7 is a solution of x minus 5 equals 2. So we're going to start off with the x minus 5. We'll rewrite our equation. And then we will substitute in the 9. And we've done that here. And 9 minus 5 is 4. Is 4 equal to 2? No, it's not. So it's not equal to. So 9 is not a solution. Let's try it over here. We rewrite the equation. Been working with expressions so long, having a hard time saying equation instead. But it has an equal sign, so it is indeed an equation. So we rewrite the equation, substitute the 7 right here. 7 minus 5 is 2. Does 2 equal 2? Indeed it does. So yes, indeed, 7 is a solution. So let's do some checkpoints here. The sum of, it says write the verbal sentence as an equation. So for 1, the sum of 3 and z, sum is to add, right? So 3 plus z, put a line through it so we know it's not a 2, is, that's an equal sign, and negative 10. Negative 10. For number 2, the quotient, so quotient means to divide. So we're going to use a fraction for that because all fractions are division problems. The quotient of m comes first, so it is the numerator. And 6 comes second, so it's the denominator. The word is equal to, and then the number 4 is what we put after the word is. So tell whether negative 5 or 5 is a solution of negative 8 plus y. So our negative 8 y equals 40. Negative 8 y equals 40. So let's do negative 8 times, and we'll substitute in negative 5, and equals 40. Negative times negative is positive. 8 times 5 is 40. 40 equal 40. Indeed it does. That checks out. So negative 5 is a solution. I'm going to guess negative 5 is not, but it's always a good idea to check. So negative 8, plug in the 5 instead. And negative times positive is negative. 8 times 5 is 40. Bring down the equals 40. Is negative 40 equal to negative 40? No, it's not. So this is not a solution. So in this case, negative 5 is a solution. Positive 5 is not a solution. Solving equations. Finding all solutions of an equation is called solving the equation. You can use mental math to solve a simple equation by thinking of the equation as a question. So here we have x plus 3 equals 11. So what's the value of x? Well, we could ask ourselves, what number plus 3 equals 11, right? What number plus 3 equals 11? I mean, we just translate it right back from a mathematical sentence over to a verbal expression, or verbal mathematical sentence. So with that said, gee, what number plus 3 equals 11? Well, 8 plus 2 is 10, and so 8 plus 3 must be 11, so 8 works. 8 plus 3 equals 11. Indeed, that's true. Here we have 16 minus m equals 9. So we can say 16 minus what number, and that's a really good way to verbally represent a variable, is to call it what number. 16 minus what number equals 9. Well, I know that 16 minus 10 equals, or I didn't want to go there. That's way too much. I know that 16 minus 6 equals 10. Well, I want it to equal 9, so I guess I need to take away one more. 16 minus 7 equals 9, so 7 seems to be a solution. 16 minus 7 equals 9. Indeed it does. For example C, 20 equals 5 times what number? Well, gee, I know my 5s, 5, 10, 15, 20. There's 4 of them, so it must be 4. So 4 is the number. Substitute it in. 20 equal 5 times 4. Indeed, it does. And then finally, D, we have what number divided by 6 equals negative 3? Well, 6 is positive, and 3 is negative, so it's got to be a negative number. And so what number could I divide by 6 to get 3? And that would be 18, so the answer must be 18. So substitute it in. Negative 18 divided by 6 equals negative 3. Indeed, it does. On our checkpoint here, we could use some mental math, and later on, some of you might be thinking, oh, I know how to solve one-step equations, because that's what this is, but we're not wanting to really get there yet. We're just wanting to use mental math. So some number minus 10 equals 17. Well, or 17. I'm spitting out the answer. My brain's getting ahead of myself, right? So I realized that 17 minus 10 equals 7, so 17 must be the answer. 2 plus some number equals negative 6. Well, if I'm on a number line, and I'm here at 2, and here's 0, and I got to get down here to negative 6, and I'm going back this way, and I go 2 spaces and 6 spaces, it must be 8, right? So it must be 2 plus 8. Well, 2 plus 8 is 10. Well, that's because it's 2 plus negative 8. We're adding a negative because we're going back the other way. On number 6 here, 3 times some number equals negative 15. Well, 3 is a positive. Negative 15 is a negative, so W has to be a negative number. So 3 times some number equals 15. Well, 3 times 5, so negative 5 must be the solution. And then finally, 4 is equal to 36 divided by some number. So in this case, well, think of it this way. I know my 4s. 4 times 9 equals 36. So S must be equal to 9. So for example number 4. Example number 4 is our lotus flower question. It says from 1998 to 2002. So that's a period of how many years? Yes, 4 years. Biologist Jane Shin Miller grew several lotus plants from ancient seeds she found in China. The oldest seed was about 500 years old. Estimate the year when the seed was formed. So we could write a verbal model for this sentence. We could say the year that the seed was formed plus the age of seed when it sprouted is equal to the year the seed sprouted. So we're going to let X represent the year when the seed was formed. So they're asking us, what year was the seed formed? And because you are only trying to estimate X rather than determine X precisely, you can use 2000 for the year when the seed sprouted. Now, at the present time that I'm making this video, it's 2020. So we're rounding back to the nearest 1,000, and we'll just think of it in thousands. So we're going to use the year 2000 for when the seed sprouted. This year simplifies mental calculation and lies within the given period time, within the given time period of this here. Okay, so maybe it's not how long it is from now. They're asking whenever she was planting it. So that's why we're using the number 2000. Not because of the year that it is now, but we're talking about the year whenever Jane planted it, which was sometime between 1998 and 2002. So that's why they're using the number 2000. So the year the seed first was formed plus 500 years equals the year that Jane is planting it. So some number plus 500 equals 2000. Well, that would be 15. Because X equals 1500, the seed was formed around the year 1500. Now, I would have thought of this, okay, it's the year 2000, the seed's 500 years old. I would have thought 2000 minus 500 is 1500, and so the year would have been 1500. So I probably would have approached that a little differently. Checkpoint here, go-kart rides cost $5 each at a county fair. During the first day of the fair, the go-kart operator takes in a total of $1,000. How many times did people ride the go-karts that day? So if you think about it, it's 5 plus one ride plus another ride plus another ride plus another ride. And we're just going to keep going until that number equals 1,000, right? Well, repeated addition of the same number is multiplication. So we're saying 5 times some number that we'll call x is equal to 1,000. Well, I'm so tempted to do this in the way that I know is a one-step equation, but we can plug and chug. Let's take a guess. Let's take 5 times, and let's say there's 100 rides, right? So 5 times 100 is 500. Well, that's not 1,000, but what I do notice is it's twice as much as 1,000, right? 500 is half of 1,000, and so we just double the number of rides. Instead of 100 riders, let's go 200 riders, and that's going to equal 1,000, right? So we now know that it's 200. So there were 200 go-kart riders that day, or 200 rides sold. It could have been fewer go-kart riders if somebody rode it more than twice. So, but there were at least 500 times that someone paid, or 200 times that someone paid $5 in order to get to 1,000. All right, guided practice on this one here. Copy and complete. A blank of an equation is a number that produces a true statement when it is substituted for the variable. So that would be a solution. Solution of an equation is a number that produces a true statement when it's substituted for the variable. What question would you ask yourself if you want to solve the equation negative 4t equals 28? Well, you'd ask yourself negative 4 times what number equals 28? Because remember, variables, we just say what number. So, and we don't actually have to solve it. They just say, what question would you ask yourself? On the next one, write verbal sentence as an equation. Tell whether 5 is a solution of the equation. So the sum of x and 10. The sum is to add. So we know that we're doing addition. X and 10, so it's x plus 10. And the word is, because we're dealing with equations now instead of expressions, 15. So we've written out we wrote the verbal sentence as an equation, and now we need to find out, is 5 a solution of the equation? Well, if I plug in 5 for x, add 10, is 5 plus 10, 15. Indeed it is. 15 equals 15. Yes, indeed it does. So that's good to go. And I'm going to leave the appetizer question alone. Really don't need to go there. Might get hungry if I do. All right. So that's all I have for lesson 2.4, variables and expressions, or I can't read today, variables and equations, where we solved equations with variables. Thank you.